In this video I will work the example from class, example number 3, that I put in the notes for the cost-benefit analysis. And this example is called the Brittany Corporation, and this corporation is trying to decide between two mutually exclusive projects, Project A and Project B. We need to answer the questions. Question number 1 involves both Project A and B, and so we'll calculate the net present value for A and then calculate the net present value for B, and then the other 3 questions only look at B. And again, remember the reason A is here is just to handle this $45,000 cash outflow. So we have a cash outflow at the beginning, cash inflows, and then a cash outflow at the end, making Project A a very special project. And then Project B has a cash flow out at the beginning, but then 3 cash inflows, so much more standard project. And as such, we can do the profitability index, the discounted payback, and the internal rate of return for Project B. For Project A, remember, because it has that negative cash flow in the future, it makes things much more complicated. And so let's start with Project A. In Project A, we'll start off in the first column. And we'll have time. We'll do the cash flow. We'll have the discount factor. And we'll have the discounted cash flow. I'll call that DCF. So you need 4 columns. And then time, there's a cash flow at time 0. The cash flow at time 0 for this project is $300,000. So at time 0, you'll see a negative $300,000. Then we see that there's $50,000 inflow, but it's evenly distributed after the first year. If we use 1 for time, then that will assume that $50,000 comes at the very end of the first year. So because the $50,000 is evenly distributed throughout the first year, we're not going to use 1. Instead, we're going to use 0.5. That's a good simplification assumption to make. Since we have multiple cash flows that are going to happen throughout the entire year, we'll just assume all of the cash flow happens in 6 months. That's about the same as the cash flow that's evenly distributed out through the year. And so that cash flow is $50,000. We then have a cash flow after the $50,000. In the first year, we now have $325,000 of cash flow evenly distributed throughout the second year. If we use 2, that would come at the very end of the second year, but we know this cash flow starts at the end of the first year and goes throughout to the very end of the second year. So throughout the entire second year, so we won't use 1 because that would assume it happens at the beginning of the second year. We won't use 2 because that assumes that the cash flow happens entirely at the end of the second year. So instead we'll compromise, we'll use 1.5, which is a good compromise position. So 1.5, and the cash flow is $325,000. And then the last cash flow for Project A is $45,000. It's a cash outflow, but it happens right at the end of the first quarter of the fourth year. So the beginning of the fourth year, it would be 3. If I use 3 as my time, that'd be right at the end of the third year or right at the beginning of the fourth year. And if it happened right at the end of the first quarter, then that would be 3 years plus a quarter. So my time here is going to be 3.25. I know that can be the toughest part of this quiz, but just do your best, because I don't count off much if you have trouble there. And again, it's a cash outflow, so we're going to use negative $45,000 as given. And so now we have our cash flows written out. Our discount rate, as you can see in this problem, there's 2 discount rates given. One is the cost of capital, which is the discount rate you're going to use for almost every cash flow, with one exception, that negative $45,000. Anytime you have a negative cash flow in the future, we need to use a different discount rate, a lower discount than cost of capital. In this case, I only give you one other rate. and that is the cost of debt of 4%. So we'll use the cost of debt at 4% only for this one cash flow, the $45,000. For everything else, we'll use the cost of debt 4% will be used for the $45,000. The cost of capital, the 7.5%, will be used for all other cash flows. So my discount factor, if it's at time 0, then you take 1 divided by 1 plus the discount rate, 0.075, raised to the time, to the 0 power, and that's going to equal 1. For the next one, we'll have 1 divided by 1 plus 0.075, or 0.0175, and we'll raise it to time, 0.5, and that will equal 0.9645. And traditionally, with these discount factors, we go out 4 decimal places. The next one, 1 divided by 1.075 here, raised to the 1.5 power, and that equals 0.8972. And then the last one, this is the tricky one, 1 divided by 1, not 0.075, but 1.04, that cost of debt. We'll raise that to the 3.25, and that discount rate will be 0.8803. And so we just multiply across. Negative 300,000 times 1, obviously it's going to be negative 300,000. 50,000 times 0.9645 is 48,225. 325,000 times 0.8972 equals 291,590. And then the negative 45,000 times the 0.8803 equals negative 39,614. To get the net present value for this project, we simply add up all the discounted cash flows, and that will give us a positive 201. So the project is acceptable. However, these are mutually exclusive projects, so we can only pick either project A or project B. So project A is acceptable because the net present value is greater than 0, but we might prefer project B. On the next video, I'll work through project B, and we'll come back and compare these two projects.